Now that we've seen Avogadro's number, we've seen moles, we've seen the mole equation, we can now look at molarity. Previously, we have seen moles, mass, and molar mass, and how these three are dependent upon one another. We've also seen how to convert between moles and the number of atoms, molecules, and particles using the Avogadro's number. We've also taken a look at the steps to reaching from a given mass to the number of atoms in a specific molecule. We put together the equations that we know between moles, mass, and molar mass, as well as the conversion between moles and molecules using Avogadro's number, and looking at the microscopic level of atoms within a macroscopic level of molecule. So at this point, if you're still confused, make sure to refer back to the previous videos and look at the sample problems. We're going to move on to talking about concentration. Moles, we have seen previously, is related to mass and molar mass. But that might not work as well when we're looking at something that requires concentration. When we say something is concentrated in chemistry, this means that we are referring to the amount of solute in a mixture, right? In a mixture, we have solutes and solvents. When something is concentrated, if you have a concentrated orange juice, then it means that you have a lot of maybe your orange juice powder, your solute, in your solvent of water when you were mixing it together to form your orange juice. Concentration is the exact same as molarity. There's just two different words to describe the same thing. Concentration, we use big C. Molarity, we use M. We can calculate the concentration of an aqueous solution. Aqueous solution is, in simple terms, is a mixture. So we can calculate the concentration by using C equals to N over V. N, we have seen before, N is moles. So this is how moles is related to concentration. Concentration has the units of big M. Moles has the units of MOL, we've seen this already. And V, as you can probably guess, V stands for volume. And volume is in decimeters cubed. D for deci. Now looking at concentration. Concentration or molarity, we just discussed, has the unit of moles per decimeters cubed, right? Because the concentration equation is moles over volume. So we put the two units together. This means that if you're given a volume in centimeters cubed, so say the problem doesn't give you decimeters cubed, well then you're going to have to convert it to decimeters cubed from whatever you're given. You will need to use this conversion. This conversion is 1 decimeters cubed equals to 1,000 centimeters cubed. 1 liter also equals to 1,000 milliliters. Okay, and liters and milliliters are probably the units that you're more familiar with when you're buying different types of drinks. But in standard SI units in chemistry, we use decimeters cubed and centimeters cubed. So we could probably equate then that, okay, well then 1 decimeters cubed is equivalent to 1 liter, and we could see that centimeters cubed equals to milliliter. So if this helps you a little bit, whenever you think milliliter, milliliter is centimeters cubed, and liter is decimeters cubed. Now let's take a look at a problem. The problem is asking find the concentration of 30 grams of chocolate powder. Say the chocolate powder has a molar mass of 156.0 grams per mole with 500 centimeters cubed of milk. So you're trying to make your own chocolate milk with chocolate powder and your solvent of your milk. The first thing you need to do is Your concentration equation requires moles over volume. You don't have moles right now, you're given grams, but they also give you the molar mass. So you can convert the chocolate powder into molar mass, mass over molar mass, which gives you 0.192 moles. Then you see that the volume given to you is not in decimeters cubed, which is what you need, so you need to convert this. So this means that you need to divide 500 centimeters cubed by 1,000 because decimeter is bigger than centimeters cubed, right? And this gives you 0.500 decimeters cubed. Now you have the two key values that are needed for you to find the concentration, and you just find the concentration by dividing them. 0.192 moles over 0.5 gives you 0.384 molar. So when we talk about the concentration, we say whatever molar. And molar is represented by the unit of big M.